Okay, so this is now day 2 of our notes. So this is binary ionic with multiple valences. So it's still going to be, I'm going to write this above, it's still going to be one metal, and one nonmetal. But the new thing is that the metal has more than one charge. So previously, so y'all can see that a little bit better. Okay, so it's still a metal and a non-metal, still something from the left and something from the right. It's still 2 total things, still binary. But this time your metal is gonna have more than one charge. So for a really long time in my class, we've looked at group 1 and we said, okay, these metals have a charge of +1. These metals here in group 2 have a charge of +2. And then we skipped this whole middle and we said these guys have a charge of +3 and then +4, and then we kind of stopped. Okay, but now we're gonna talk about all these here that have multiple charges and some of these down here that have multiple charges and how to find them. So linked under course resources, you have a chart here. And it says common polyatomic ions, but there's also this bottom section that we're gonna use today. Okay, we're gonna use the top part tomorrow. So this bottom section lists all the elements that have more than one charge. So if you look a little bit closer, you can see that antimony has a charge of +3, but it also has a +5, okay? Bismuth has a charge of +3, but it also has a +5. Chromium has +2, +3, and +6, okay? Cobalt has +2 and +3. So you don't have to memorize these. They're literally on this chart right here for you, and I'm gonna show you how to use that today with some examples. We're gonna start our rules and our steps exactly the same like we did in the other video. So you should already have this side filled out. We're talking about the middle today. This is day 2 of the nomenclature notes. Nomenclature just means naming system, okay? And we're gonna start here with, same way we did last time, we're gonna start with writing the name. So we have the formula, and we need to write the name, okay? So I'm gonna highlight that, just like I did last time, trying to keep it consistent. All right, so our first step this time is we're going to name the metal. That's the same. All right, our step 2 is gonna be different and new, okay? So step 1, name the metal. Step 2, we're going to write parentheses. Probably didn't know how to spell that word until today, did you? With Roman numeral charge. Okay, we're gonna write parentheses with a Roman numeral charge, and you'll see how that looks. It's on that polyatomic chart I showed you, so you don't have to worry about it if you don't know what you're doing. Okay, and then our third step is we are going to name the nonmetal. And change ending to "-ide" again. Okay? So that part, we're still gonna name the nonmetal, and we're still gonna change the ending. That didn't change, okay? The new part here is that we're gonna write these parentheses, and you'll kind of see how that looks in just a second. So here's our first example we're gonna do, PbCl4, okay? So our first step says name the metal. Whatever's listed first is gonna be our metal. So the name of Pb from the periodic table, it's right here, is lead. So we've named the metal. We've accomplished step number 1. Step number 2 says write parentheses with our Roman numeral charge. Well, we don't know the charge yet. We'll come back to that in just a second. Then we're gonna name the nonmetal and change the ending to "-ide." So the nonmetal is Cl, and the name of Cl is chlorine. And then we have our list of nonmetal endings. You'll start to get used to some of these. All right, chlorine's ending is now gonna be chloride. So we're gonna write chloride. And remember, the "-ide" just means that it's being bonded together to this metal. Remember, spelling counts. Make sure you're paying attention to your spelling, okay? If you don't pay attention to your spelling, it's gonna be counted wrong, okay? If you forget the H in chloride, it's wrong. I know that's annoying, but you have to use the periodic table and check your spelling, okay? So now to figure out this charge here, okay, your formula is already gonna have been crisscrossed, okay? So I want you to think about it this way. I'm gonna grab a pencil. When we've already crisscrossed this, okay, it already exists crisscrossed. The number came from over here, and this number here came from over here. So we can actually look up chlorine's charge on the periodic table. We know chlorine had a -1. So that's what is above that. So we know chlorine has a -1. So that's what came here, right? And on this side, we have a 4. So that means that came from over here. So that is a +4. Now, so you're literally going to look at whatever number is on the outside, and that's going to be your charge of the metal. Now, remember before, the other day, yesterday, when I said we have to reduce. So sometimes your formula has already been reduced, and maybe it's not a 4 because this was also a 4, and it just became 1 and 1. So what you're going to do is you're going to uncrisscross. You're going to say, okay, this is supposed to be a 4, and then you're going to check this polyatomic list with this bottom section here, and we're going to see if +4 is a choice for lead. Okay, so our list here is in alphabetical order. So lead starts with an L, and here's our symbol, Pb. So the two choices I have for lead are either Pb with a +2 charge or Pb with a +4 charge. Okay, so +4 is a choice for lead. If it had already been reduced and I said it was supposed to be Pb +1, +1 is not a choice for Pb. So I knew that it would be wrong and I would have to have done something else. Okay, so the charge that's going to go here in the parentheses is going to be the Roman numeral form of +4. It's not a regular 4. And if you don't know how to do that, the +4 is here, and I wrote it for you on this polyatomic chart on the bottom in Roman numerals. So you're going to write it as IV in parentheses. Okay, so that's how that's going to look. So this would be our answer to that. You're only going to use a Roman numeral if the metal is on this list. All the other metals on the periodic table do not get a Roman numeral. If you try and stick a Roman numeral on everything, it is wrong. Only the ones here, right here on this list, on this polyatomic chart, down here at the bottom, only these guys get Roman numerals. Okay, let's try another example. This one is Cu2S. Okay, so we're going to do the same steps. First step here says name the metal. Well, the name of Cu from the periodic table, it is right here. The name of it is copper. Okay? And step 2 says write parentheses with the Roman numeral charge. Copper, we know, is going to need a Roman numeral because it's in this section, and I don't have a charge there. And the reason why there's no charge there is because it has more than one. All right? And then we're going to name the nonmetal. We'll come back to the Roman numeral here in a minute. We're going to name the nonmetal and change the ending. Well, S has a name. S's name is sulfur. So we're going to change that to sulfide. Okay? Name the nonmetal and change the ending to "ide." So now we've accomplished that. So let's figure out what charge that copper is using in this formula. Remember, it's already been crisscrossed. So that means that this was over here, and that's a -2. And you can check that. S has a -2 above it. Okay? So that means over here, if there's not a number, it's like a 1. Okay? So this shows me that this should be using +1. But we need to make sure that it hasn't been reduced and see if Cu actually has a +1 from our list. So we're going to come to our multivalent list, which is the polyatomic chart. We're going to find copper. Copper's right here. And the two choices for copper are +1 and +2. Well, it's using a +1 because that's what's on the outside. Okay, whatever's on the outside, on the other side of the nonmetal, is the charge of the metal. So that means that I'm going to write it as just an I, because that's how you write it in Roman numerals, a capital I. Cu +1 is copper with an I in parentheses. So that's how that looks. And this would be my answer. Okay? Now, let's talk about writing the formula. So I'm going to use the same colors I did yesterday. Writing the formula. We're going to start the same way. Go ahead and highlight that. So you see that they're kind of sectioned off. Like, this is how you do the names. This is how you do the formulas. This is how you do the names for metals that have more than one charge. This is how you do the formulas with metals that have more than one charge. All right, so our first step is going to be very similar. Okay, it's going to be write symbol and charge from parentheses for the metal. All right, we're going to write the symbol and the charge from the parentheses for the metal. And you'll see how that works when I do my examples. All right, then our step number 2 is write symbol and charge for the nonmetal. And that's going to come from the periodic table. Okay, and then our third step is going to be just like this one. It's going to be to crisscross and reduce. And you're going to see that a ton throughout these notes. That last step is always going to be crisscross and reduce. Okay, so now let's do some examples here. So our first one is this. I'm going to write the name and then we're going to write the formula. So we have mercury 2 oxide. And we're going to write the formula. Okay, so I have the name and I'm trying to figure out what the formula is. That's what these steps are for, to write the formula. So step number 1, write symbol and charge from parentheses for the metal. So my metal is mercury. So if I come to the periodic table and I find the name mercury, I see the symbol is Hg. All right, now it's in this section here on the periodic table where I can't figure out the charge, but I can use the name. The charge it's using is right here in parentheses, okay? So it's using a +2 charge, okay? It came from the parentheses. That's what the rule says. Write symbol and charge from parentheses for the metal, okay? Then our second step says write symbol and charge for the nonmetal. Well, oxide is oxygen, so that symbol is O, and the charge is right there. It's -2, okay? So I've accomplished step 1 and step 2. Step 3 says crisscross and reduce. So I'm going to bring this 2 over here and this 2 over here. Remember, the positive and negatives disappear. And we said and reduce. When the numbers match, they basically cancel and become 1. So this real answer is going to be HgO. Okay? Let's try one more. We have iron 3 bromide. Iron 3 bromide. So go back to your step 1. It says write symbol and charge from parentheses for the metal. So iron's symbol, if you don't know, on the periodic table, it's kind of weird. Doesn't start with an I. It's Fe. So here's my Fe, and the charge comes from right here. This 3 right here in parentheses tells me that it's using +3. That's a little bit easier, I think. All right, then bromide is bromine. So that symbol from the periodic table, bromine's right here, and the charge, or the symbol is Br, and the charge right above the group is -1. So I'm gonna write Br with a -1 charge. All right, step 3, crisscross and reduce. So this 1 comes in between, this 3 goes on the outside, the positives and negatives go away. So I don't write 1s in formulas, and I can't reduce a 1 and a 3, they're not the same. So it's gonna be FeBr3. Okay, remember the charge of the metal will always go on the outside. The charge of the nonmetal will be on the inside because you're gonna crisscross them, okay? The charge for the metal comes from the parentheses if you're given the name. You gotta look at the parentheses if you're given the name. Now, some of these on your assignment will be a little bit mixed, so it's not all just this one thing we talked about today. It's both things that we've talked about. So if you have a name and you don't have the parentheses, that means the charge is going to come from the periodic table. It's in one of these groups where we can figure out the charge, like calcium's charge is +2. It does not get a Roman numeral. Only the ones on this list here get the Roman numeral. So you won't find calcium here because it's gonna be from the periodic table's charge, okay? So that's kind of the difference there. Make sure you take these notes and make sure you use them when you answer your questions.